Okay, so looking at question one, I kept in mind the order of importance of the operation. So I knew that parentheses is the most important, and then star, concatenation, and then finally union being the least important. So looking at the expression, I saw that 0 star came first, and so I created the NFA for that one. And then once that NFA was created, I went ahead and concatenated that NFA with the NFA for 1. So that would take care of what would be in the inner parentheses. And then from there, I focused on concatenating 1 and then the NFA that was previously created. And then from there, finally, I would create the NFA for whatever was inside the parentheses to the NFA of 0. Or I'm sorry, I went ahead and unionized 0 and then whatever was inside the parentheses. And so I just followed the steps for star, which is create new start state, make an if substate 2, create transitions from the new start state to the old start state using epsilons, and then finally create transitions from the old except states, keeping them except states, and those transitions would lead to the new start state using epsilon. And then the steps for concatenation would be to keep start state of the first NFA, except states of the first NFA or no longer except states, create transitions from the old except state to the start state of the second NFA using epsilon. And then for union, it would just be to create a new start state, and then from that start state have new transitions using epsilon going to the old starting states. And then for question 2, the first step was to find all the states that could be reached from the start state of the original NFA using epsilon. So here I would look at my NFA and I would go to the starting state, which would be state 1. And okay, so from state 1, I had 2 transitions coming out of it using epsilon, and that would lead to state 2 and state 4. So I knew that in my DFA, my starting state there would be 1, 2, and 4. And then the next step was to figure out the transitions, and I did that using the table. So I would first focus on symbol 0. And okay, so looking at state 1, I would see if there were any transitions coming out of it using using symbol 0. And then in this case, there weren't any, so I would go to state 2. And then I saw that there was one transition coming out of it using symbol 0. And that transition led to state 3. So I went ahead and wrote that down in the table. And then I did the same with state 4. And then I saw, well, state 4 didn't have any transitions coming out of it using symbol 0. So okay, so I did the same thing for symbol 1. And I went back to state 1 and I saw there were no transitions. And then, well, no transitions using symbol 1. And then state 2, there was no transitions using symbol 1. And then state 4, there was one transition using symbol 1. And that transition led to state 5. So I went ahead and wrote state 5 down on the table. And then from state 5, I saw that there was a transition coming out of it using epsilon. And so I went ahead and wrote down state 6, which is what it led to, down on the table as well. And then from state 6, I checked to see if there were any epsilons coming out of it, and there weren't. So I stopped there. Okay, so now for symbol 0, I had state 3. So I went ahead and wrote down state 3 down on the table, like on the left column. And I knew that that would be a state in the DFA as well. And then 5 and 6 were also going to be a state. And I went ahead and wrote that down on the left side of the column as well. So I continued that process of, okay, focusing on one state and then seeing if there were any transitions coming out of it using the appropriate symbols. For state 3, there was, since state 3 didn't have any transitions coming out of it, I just wrote down sync for both symbol 0 and 1. And then sync would be a new state in my DFA as well. And then as I kept filling out the table, I saw 7, 8, 9 would be a new state, and 8, 9, 10 would be a new state. So when creating the DFA, I would just make sure to create the appropriate transitions coming out of the appropriate states using the appropriate symbols. And then so for the third step, it would be to mark all the accept states. And by that, I would look at the NFA, and I would go to all the accept states in the NFA, and I noticed that 3, 8, and 10 were accept states. So in my DFA, I would mark all the states that had 3, 8, and 10 to also be accept states. Okay, so for question 3, I went ahead and did steps 1, 2, and 3 together. So I created a new start state, connected that with an epsilon to Q1, because Q1 was the previous start state. And then I created a new accept state and connected Q1 to this new accept state using epsilon, and then Q3 to this new accept state using epsilon. And the reason for Q1 and Q3 is because they were the old accept states, but they're no longer accept states. So the first removal that I did was Q2. So I kind of just saw that from Q3 to Q2 there was a transition using 0, and Q2 to Q1 there was a transition using 0. So I went ahead and concatenated those two zeros. And then from Q1 to Q2, a transition using 1, Q2 to Q3, a transition using 1. So I went ahead and concatenated those. And then Q1, I did the same process, except that Q1 did have a lot more transitions going into it and out of it. So 3 going into it, 3 going out of it. So, okay, so the way I did this is I saw Q3 had a transition going into Q1, and Q1 had a transition going back into Q3. So I went ahead and concatenated those transitions together to get the two zeros concatenated with this new 0. And then I did that with the rest. So starting state from Q1 to Q3 had transitions, and those were concatenated together. So I ended up with epsilon, 1, and a 1. And then the epsilon, I got rid of it because whenever epsilon is concatenated with another number, it could just you can just get rid of it. And then from Q3 to Q1 to the accept state, I went ahead and concatenated those transitions together. So I ended up with epsilon and 1. And again, I got rid of the epsilon. Okay, so I noticed that there were two transitions going from Q3 to the accept state. So one transition was using the symbol 1, and then the other transition was using epsilon. So I went ahead and unionized those two. And then finally, it was the removal of Q3. So I would just concatenate the transition from the starting to Q3. 1 and 1 would be concatenated with 0, 0, and 0, and then those 3 zeros would have a star because it's a loop. So whenever there's a loop, you want to add a star to the transition symbols. And then from Q3 to the accept, there was another concatenation of this one. And yes, so that's it. Okay, so for number 4, I use a string a to the p and then b to the p plus 1. So p plus 1 because the language says that m has to be greater than n. So I went ahead and said that x, y, y, z is not part of the language because I assigned x and y to the b's, to the a's. And I assigned z to the b's. So I used an example, and I said that p was going to equal to 2. So it would be a to the exponent 2, and then b to the exponent 2 plus 1. And then, yeah, so again, x and y would be my a's, and Z would be my B's. So there would be a total of 2 A's and 3 B's. And then after adding the Y, the second Y, so it could be X, Y, Y, Z, there would be a total of 3 A's and 3 B's, which is incorrect because the language says that M has to be greater than N. So therefore, it's proof that L is not a regular language. So for number 5, I would focus on the first part, which was to accept strings that had an even number of A's, and then I would reject, or not reject, but I would send the odd numbers to a state that wasn't an accept. And then I focused on the second half, which was to have at most 3 B's. So the first B I would accept, the second B I would accept, and the third one I would accept, but the fourth one I would send to a state that wasn't an accept, and that state would just loop the B's if there were any more. Okay, so for number 6, I went ahead and made a short list of all the strings that needed to be accepted. So for the first one, which was 0, I knew that this had to be accepted because 0 is in an odd position. So 0 was accepted, and then 0, 1 was also accepted because the language didn't specify anything that needed to be held in the in the even positions. So 0, 0 was accepted, and 0, 1 was also accepted. But if the string started with 1, then it didn't matter what came after that, it was immediately rejected because obviously it doesn't satisfy that rule of having a 0 in the odd position. Okay, so for 7, I created an NFA from the given expression, and then that NFA, I turned it into a DFA, and then that DFA, I basically did the opposite. So whenever there was an accept state in the DFA, I would just, in my answer, I would make it a regular state. And then the sync, I would make that the accept state. And yeah, so the way I would try it out was to grab a list of examples from the first DFA of the strings that were accepted and the strings that were rejected. So I would just grab some of those and then test them in my answer to see if everything worked out well. And then for number 8, I did the exact same. So I created the NFA and then the DFA, and then I went ahead and did the opposite of the DFA, and that was my answer.